All right, let's start. Hi, I'm Wojtek. I work at Google in the Android developer relations team. I work mostly with technologies like Kotlin and Android Studio, but also Play. And that's what I want to talk to you about today. We're going to talk a little bit about the app bundle format and the possibilities it opens up for developers and for your apps and for your users as well. Now, I know there was a talk yesterday about modularizing your app, which was great, by the way. I'm going to talk about it in a little bit from a different side. So in the talk yesterday, you might have heard about how to organize your code between library modules, how to communicate between these modules, how to do navigation, how to organize resources and stuff like that. That was a very good in-depth look at how to refactor your apps. Today I want to talk a little bit about dynamic features, which is a new way to modularize your app on Android, and what technologies exist today in Play and also in Android Studio that let you use these dynamic features to actually deliver your app in a more customized way to your users. Okay, so let's start with the basics. And the basics are the Android app bundle, which is kind of a new format for distributing your apps on Android. And I'm hoping that by the end of this talk, everyone will understand why it's a good idea to move to bundles. I think everyone should use it, except maybe for game developers, since if you're using APK expansion files, that's currently not supported for app bundles. But we will have other offerings for these game developers to be able to switch to bundles soon. Okay, so why do we even need a new format for publishing your apps on Android? We have APKs, right? And the APK file format contains everything that's needed to run your app on a user's device. The thing is, the format is already over 10 years old. It evolved very little since the very beginning, and it has a few shortcomings. First of all, your app is monolithic, which means an APK contains all the app code and all the resources that might be needed to run your app on the variety of devices out there. So different screen sizes, different CPU architectures. It also contains all the languages that your app ships, and that sometimes that can be actually quite a lot of data. And second of all, there's a slight problem if we want to do any kind of optimizations for a user's device. Once the APK is shipped to Play and signed by you, by the developer, the APK can never be modified. So there's no way we can apply any kind of optimizations to the file that you ship to Play. Now, there was a multi-APK solution where you would produce basically a lot of APKs targeting the different screen configurations, the different CPU architectures. But that was very difficult to use for developers. You needed to keep track of many version codes, upload tons of artifacts to the Play Store. It was very unflexible. It created a lot of problems instead of actually solving them. And so about 2 years ago, I think, we created this new Android app bundle format, which is a format for publishing apps to the Play Store. And let me explain what that means. So it's an intermediate format that is used only for publishing your apps to Play, which means from now on, you export a signed Android app bundle from your project in Android Studio. You upload it to Play, to the Play console. But then what actually happens is the Play console, the Play infrastructure, takes that AAB and it generates a set of APK files, just like the files we used to have. By the way, this happens using a tool called Bundle Tool that is open source. If you want to look into how this process works, you can download it from GitHub. You can try it yourself. It's exactly the same thing that Play uses to generate the APKs. And then once a user of your app goes onto Play and requests the installation of your app, Play will create and deliver a number of APKs. So it chooses specific APKs that target only the user's device configuration, again, such as screen size, language, and CPU architecture. But wait, how come one app can consist of multiple APKs? What does it mean that multiple APKs are delivered and installed? Now, this thing called APK splits actually existed in a platform for a long time. Android 5.0 Lollipop introduced the concept of APK splits, whereas a single application, so running a single process, visible as a single app to the user, can actually consist of one or many installed APKs that are installed together in one location. They still exist as separate APKs, but they are run as if it was one application. And so, for the first time with Android app bundles, the Play Store can actually use this split APK system that Android supports and deliver specific splits for your one containing the base code and resources of your application that are not configuration specific, and then only deliver one split APK that contains the language that the user has set on their device, one split that contains the resources, mostly graphics, that target the screen configuration of the user. And same with native libraries. If you have any in your app, if you have any SO libraries or DLLs, that will be delivered as well. And they are installed together. They're still visible as one app, but they let you reduce the amount of data that needs to be sent and installed on the user's device. Is it backwards compatible? Yes. Actually, since we can now do these transformations on the Play Store, we can detect which kind of device is requesting to install your app. Even if you use app bundles and the user is on a version of Android below the minimum that supports split APKs, we can still build a universal APK or a fused APK that will contain all these things I just mentioned and deliver this one APK to all their devices. So your app still continues to work. You can safely switch to app bundles. How to switch? Well, now look at it very carefully. It's very difficult. You have to change your Gradle invocation from assemble release, which produces an APK, to bundle release, and that's it. So you don't need any code changes. Everything should work as before, as long as you remember that now you only have the language resources that your user's device is requesting, only the density for the bitmaps that you're delivering, and so on. But for most cases, it should work without any changes. Now, I just want to mention, I'm not going to talk about it a lot during this talk, that there is one more prerequisite, actually, for using app bundles. Since I mentioned that from now on, if you upload a bundle, the Play Store is the place where the actual APKs are generated, and APKs need to be signed in order to be installed on users' devices. You need to sign up for app signing by Google Play. This is where you either upload your signing key to Play, or you let Play generate a signing key for you. And from now on, Play will be able to transform these AABs into APKs and perform the necessary optimizations and sign the APKs on your behalf. Now, this actually makes your key a lot safer, since if you ever lose your key and you never uploaded it to Play, so you didn't sign up for app signing, if you ever lose that key, there's nothing we as Google, as Play, can do to help you. If you lose your key, there's no way you can update your app. With app signing, the key is securely stored, so that even if you lose the key, we can still help you update your apps after that happens. Okay, so this is the basics. App bundles are for every app, with a caveat for game developers. You get huge size savings for your users, both on download, for storage on devices. But there's more. So app bundles is just the first step. And now I want to talk about how you can modularize your apps to deliver an even more customized version, a more customized experience for your users. So let's talk a little bit about the scenarios when this might be useful. Why would you want to modularize? Why would you even spend the time and your team's resources to do it? So let's say you have an app that has a core feature set that most of your users use, but then maybe you want to include something that maybe almost no one will use, but it's still important to have. Maybe only 5% of your users, maybe less, maybe more, will access that part of your app. To give you some examples, you could have a ride-sharing app where most of the users are the actual riders who are hailing the ride, but some of your users are the actual drivers, right? So maybe you want to modularize out that part that the driver uses and only deliver it if a user signs up as a driver. Another example could be let's say you have an app where you have payments, and you want to enable users to scan their credit cards with some kind of big native library that weighs 10 megabytes, but maybe only 5% of users actually use that functionality. So why not deliver it when it's needed, but not actually deliver it from the very beginning for everyone? Another case, maybe you have a feature that relies on specific functionality being there on the device. That can be a hardware or software capability, such as a device supporting AR, so augmented reality. If you're working on an app that has an AR component, it's probably, again, heavy with native code, with 3D models, resources, but maybe not everyone will be able to use it. You only want to deliver it to devices who actually support it. Or maybe you have a feature in your app that only works from a certain Android versions. Why would you deliver it to all the older devices? And you can also think about targeting things per country. So maybe you have a different payment provider in Poland, maybe a different payment provider for the rest of Europe, and you want to deliver only the code that deals with that to people in those countries. Now, this is a funny use case that I've heard of, and it's actually something I will talk about today, how you can support it. You know, some apps, when you open them for the first time, they show you this beautiful screen, a login experience with a video in the background where happy people use the app and invite you to sign in and use it. And then once you sign in, once you do that once, you never get to see that video ever again. But a video is probably, again, heavy. It can take tens of megabytes, right? And so it would be nice if you could get rid of that after the user signs in for the first time and not keep it on the user's device forever and just wasting the memory on the device. Then there's this thing called instant apps that lets you deliver your full app, or rather parts of your app, as a full native experience to users when they click on a link, but they never actually have to go through the Play Store and explicitly install the app. That's possible too. I will not cover that in depth today, but what I'm talking about today is also applicable to instant apps. And finally, if you watched the presentation yesterday, it doesn't have to be a user need, right? You might want to just modularize your app to make sure that you have a clean modular architecture and that your teams can work faster and in parallel without actually affecting the code from separate modules. So it's also good for you as a development team. So all of these scenarios we can cover with the functionality that app bundles unlock with something we call dynamic delivery or customizable delivery. And I'm going to talk a little bit about how you can configure your modules in your app to enable them to be installed on demand. So only whenever a user actually navigates to the part of your app that utilizes this module, you pull it down from the Play Store, you install it on the device. Then there's conditional modules, which are installed at install time, but based on specific hardware and software, or maybe even regional requirements for the device. Now, installed modules, these are the ones that are installed with your device, so they're purely used if you want to have a modular code base, but they don't have any specific conditions. And then instant modules for enabling that instant app experience. Okay, so how do you actually start thinking about it? How do you start adding it to your code base? I assume you've switched to an app bundle. You can build a bundle now. You can upload it to the Play Store. How do you start adding actual dynamic feature modules? So if it's the first time you're doing that, if you're in Android Studio, if you create a new module using the wizard, it will actually guide you. It will let you select a dynamic feature module. It will guide you through creating that in your project. And what it will generate is, of course, it will add the module, the folder structure, and then it will go into your main applications manifest and add this metadata about dynamic features that are present in your project. And it will list the names of the features that you've created. If you're creating the first one in your project, it will obviously just list one. This is just an example if you have many. Now, if you look at the actual new module that you created, that's a dynamic feature module, you will notice that it uses a different Android Gradle plugin, com.android.dynamic feature. And there's one really, really important part that you will notice. If you look at the dependencies section of that module, you will see that it actually depends on the base app. So it's a different situation than, for example, what was described at the talk yesterday, where with the usual Android library modules, you would get a structure like this. You will get your base app at the top that depends on libraries that depend on more libraries. In this case, it's very important to understand that if you use the dynamic feature module structure that's available for app bundles, you get something like this, where the features that you pull out of your code as separate modules when you modularize your app, these will depend on the base app module, and then the app can, of course, depend on libraries. And features can depend on their own libraries as well, but they will be packaged into these features. Now, the app module still remains the entry point to your app. This is the part that you build. So if you're building an app bundle, you run the task from the base app module. But what it will do is it'll look at that metadata that was added with listing all the dynamic features, and will go into each one of them and build them as well, and include everything in the app bundle structure. Now that structure has very serious implications on what you can do, how you can access code at compile time. Because a feature depends on an app, just looking at the way the direction that dependencies go, that means you can freely access any code from the base app and its libraries in the feature module. But the opposite is not true. An app cannot directly access, so cannot directly instantiate just by typing the class names from the feature. It cannot access that code because it's not visible at compile time. The app does not depend on its features. What it can do, and what you have to do in order to be able to access the code, is you have to rely on reflection. Now at runtime, once these APKs are downloaded by Play and installed, again, as I explained, using the split mechanism, the split APK mechanism, they again run as part of a single app. So at runtime, everything is available using the single class loader. The classes can be instantiated and communicate together as long as the split APK is installed. So as long as the module, the feature that you're trying to refer to, is installed. And of course, as I explained, it might happen that, for example, on-demand modules might not exist on the user's device until you actually go down and pull them down from the Play Store. So how can you think about accessing code from these dynamic feature modules? I mentioned reflection, and in fact, all the scenarios I will describe now use reflection in some form or another. But if your feature contains a self-contained UI, which is, let's say, an activity. So you have a feature that has a certain user flow, and you want to launch into that feature, but from now on, that activity, that feature is taking over the screen and kind of does its own thing. It's actually pretty easy. You can still launch the activity using an intent. It's not a problem. And the only thing you have to remember, you have to use this version of creating the intent where you pass in the class name and the package name as strings. Because like I said, you can't access the actual class, so you can't set the class name of the activity on the intent. You have to pass it in as strings. But then after you launch it, you can do whatever you could do normally in the feature activity. Similar with fragments, if you have a single activity app and you just want to switch to a different fragment, you have to use reflection to create an instance of that feature fragment. Now, normally fragments have a no arguments constructor, so the reflection call is fairly simple. You find the class again by name by passing in a string. You create a new instance. You cast it to a fragment, and you can pass it to the fragment manager and do a transition to the new fragment. And now, since your new fragment is visible, you're running inside your feature code, you can normally access whatever you shipped in that module. Now, for features with no UI entry point, where you don't have a simple activity or a simple fragment to just call and put on your screen, it's not really rocket science, but it's usually off-putting for many developers that you have to use reflection. But actually, just thinking about the common software development patterns that we learned and use, it's something that can be solved pretty easily by creating an interface for your module. So let's say you just need to access a class. Again, maybe it's a credit card reader that just offers you this entry point where you give it an image and it tells you what kind of credit card data is on it. You create an interface for that in your base app module, but the actual implementation is supplied by the dynamic feature. At runtime, when you write your code, when you need to access that class from the dynamic feature module, again, you create it by reflection, just like in the fragment example. You cast it to the interface that you have in your base module. And from now on, since you have a handle to that interface, you can normally call methods on it without using reflection anymore. So you could get it down theoretically to just one reflection call. And from then on, you're safe calling methods on it. It gets a little bit more complicated for those of you using Dagger in your applications to manage the dependency graph. Since normally, if you modularize your app, if you create various modules and scopes and Dagger components, what you would probably do is create a subcomponent for many of your modules. And this is not possible with dynamic feature modules. Just because, like I said, the classes from dynamic feature modules are not visible at compile time, so you cannot use the class names when defining the component that has subcomponents. What I can suggest you do is you look into something called component dependencies. It's a feature of Dagger that lets you break up this cycle and not rely on that dependency going that direction from app to libraries. And it doesn't have a lot of documentation. If you go on the component class from Dagger, there's a slight note at the bottom explaining what component dependencies are. But if you actually want to see how to use it with dynamic feature modules, I wrote an article on Medium, so I just suggest you find it if you're interested. It talks a little bit about the reflection cases and also lists the Dagger solution together with a sample on GitHub that you can look at and try to maybe copy a similar solution to your app. Okay, so now that you've taken the time and pulled out some of the feature code into your dynamic feature modules, you solved all the problems I just mentioned, you can now call code from features. How do you actually tell the build and Play Store about one of these scenarios that I described before? So how do you make a module on demand, or how do you create these conditions when a module would be installed on a user's device? Now, if you went through the wizard for a new module, I think the last screen would be this, where you define a module title, it would be user visible, and then you have a drop-down where you can select from one of these types of modules. The first one, on demand, so only install the module when the user actually requests it during runtime. Include module at install time, that's probably the most boring one. It is installed together with your app, so no big change there. And third one lets you specify conditions. So I'll go into detail on the actual XML code that's generated if you select any one of these. So when you do that, when you go through the wizard, this is what will be added to your Android manifest in the in the module code. There's a new section with a dist for distribution prefix, and it lists all the options that the module has. One of them will be delivery, where we will define these conditions for when the module should actually be installed with your app. And I just wanted to mention the fusing attribute. Remember when I told you about how we support installing app bundles or other the APKs generated from app bundles on older devices? If you set the fusing attribute to true, this means this dynamic feature module, even if it's on demand or even if it has conditions, it will still be fused into the APK that is delivered to older devices. If you don't want that to happen, you should set it to false, and that module will simply not be available ever to devices before Lollipop. Okay, so how do we specify the delivery options then? Like I said, the simplest one, the most boring one, is just install time. This means this dynamic feature module will be installed together with your main app whenever the user downloads it from Play. Cool. There's not much difference for you here what you can do with it. However, there's one very interesting thing you can do with an install time module that I will mention later when I describe the actual API for working with this. Now, install time modules, like I said, can also have conditions based on device features. So you can list condition, device feature, and say, for example, only install this module if the camera on the device supports AR, so augmented reality. Or you can list any other device feature from a list of well-known identifiers here that we list in our documentation. Now you can also deliver modules based on user countries, and here you can work with this two ways, based on the exclude flag here. So if I say exclude false, this means only deliver my this installed module to the countries I listed. So here, only deliver it to users with country code PL, and more country codes if I list them. If you set it to true, then the opposite will happen. Your module will be delivered to everyone except for users in this locale, so PL, for example. And finally, you can specify a condition based on the min SDK of the user's device. So if you have a feature that only works on newer devices, then you can specify that and only install it whenever the user is on min SDK 24, for example. And finally, on-demand modules, probably the most interesting case, because these modules don't get delivered to the user's device automatically at all. When a user installs your app from Play, this module is not present. You cannot call any code from this feature because it's simply not there. It's not on the device. Your app would crash if you try to do that. So how do you actually then tell Play to install that module? Well, we have a new, fairly new library called PlayCore. It's a library that's made to work together with Play Store on the user's device to interact. It's an interface between your app and the Play Store on the user's device. And it lets you do, for example, downloading of on-demand modules while your app is running. But it can also do a lot more things and also coming in the future. So this is the name of the artifact. You specify it as a dependency of your app. It gets downloaded from our Maven. Currently at version 1.6.3. And yeah, this is basically the parts of the library that are available for you now. It enables on-demand splits installation. It also enables installing new languages into your app. This is not something I'm going to talk about a lot today. However, if you remember at the beginning, I said that bundles, when we optimize the delivery for a user's device, we only deliver the language that the user set in their operating system. Now, I know some of your apps, for example, use an internal language switcher where, for example, I set my phone to English, but I install a Polish app, and I would like to still set the app to Polish, right? Just with bundles, I couldn't do that because English is not installed with, Polish is not installed with the app. However, using a similar mechanism that I will describe for on-demand modules, you can use it to pull down languages whenever a user requests this switch of language. It also contains split emulation, which I will explain next. And there's one more big part that I will not talk about during this presentation. PlayCore library enables you to do in-app updates. So whenever there's a new update for your app, you don't have to launch the user into the full Play Store experience and ask them to update the app. You can do that within your app with Play's help. Okay, so what is split emulation? Why do we need that? Why am I talking about it first when we're supposed to talk about on-demand modules? Well, I would say split emulation is a prerequisite if you want to use on-demand modules and many of the other conditional delivery options. And that's because on many previous Android versions, now I mentioned that splits are available from Lollipop, but even in Lollipop and a few next versions, there were still slight changes happening to how splits work with the framework. And so we didn't want developers to have to know about these implementation details and restrictions that the operating system puts on splits. And so we have a split compat class that takes care of managing and installing these splits that are dynamically installed with your app, making the API the same across all the Android versions. And you don't have to worry about supporting the older and the newer ones. How to use it? If you don't have a custom application class, you can just extend from split compat application, and we take care of the setup for you. If you are using your own custom application class already, you simply have to add the snippet in your attach base context in the application and simply install split compat before anything else happens in your app. This makes sure that now whenever we download and install new on-demand modules from Play, they will be recognized as part of your app automatically. Okay, so what next? This was split compat. Always remember to use it, even if you're only targeting the newest Android version, which probably none of you do. You also want to support older Android versions. Still, always use split compat if you work with any of these APIs. Okay, now the second part is the split install manager. This is the part that you use for actually installing on-demand modules into your app. So like I said, if you want to access any code from a dynamic feature module in your app, if that module is not installed and you try to do that, your app would crash. So the first thing you want to do is always before you go into a code path that uses any of the code from a DFM, always check if that module is installed. It's a little bit similar if you work with permissions on Android. Whenever you, for example, want to take a photo, you need to always make sure that the user has granted a camera permission, right? So you always have to guard these code paths before you go and go through them. So here, you just check, is my module installed? Can I use it? If yes, cool. You can go and do the reflection, get the stuff from the dynamic feature module and continue calling it. If not, then you should request module installation and wait until that is completed before you're able to access code. Now, the API is a little bit complicated, just because if you look at the code here, I create a split install request. I request the installation of my feature 1. And then when you call start install, what you get is a task. So this call is asynchronous. What you get is a task. And even though it has an on-success listener, it doesn't mean when you go into that listener, if you get a callback with a session ID, this doesn't mean that the module is installed yet. This means that the request for installing the module succeeded, and from now on, the install flow will take place. Now, you should also, of course, handle any exceptions. So at this point, maybe there was a problem communicating with Play, maybe something else happened. So you should always handle the exceptions on this as well. Okay, so now let's go through the happy path. So let's say you got a session ID, the request succeeded, and now the installation is actually only starting. It didn't finish installing the module yet. So what you should do next is you should start monitoring the install progress. So this is how it looks. Every time before you actually make the installation request, you should register a listener somewhere. If you're doing it in an activity or a fragment, you could do it in something like on start. If you're doing it in a view model, you can just install it whenever the view model is created. And then always remember to clean up. So if a user navigates away, if the installation fails or is canceled in any way, always remember to unregister the listener. Or for example, when you destroy your view model. Now, so let's say you got these two calls, you have a listener registered, and the listener is actually a split install update listener, and you get state updates whenever a module installation is in progress. So we started in the previous step, now we're getting updates. First of all, you want to check if the session ID is the one you got from the previous call. So here you get a session ID for your request, you save it somewhere, and then in the listener, you actually look if the updates are destined for your specific installation. And then you respond to events. Now, of course, you will get progress events about the bytes downloaded and how many are, how long it will take. You should also handle any cancellation, any errors, network errors, stuff like that. You should make sure that the user is aware of what's going on and always try to show the progress and what's going on in your app. But I just want to mention two very important states. One of them is installed. This is the final state when everything went correctly. This is when the module is installed. You can start using it. The thing is, if you want to use it right away from the same context, if you want to load, for example, load resources from that module you just installed, you need to call split compat install on this context again. And then you can use the split. You can use code and resources from it. And another, and of course, remember if you have a UI like this, if the installation was happening in the background, remember about good UX patterns and never, since it's a very asynchronous operation, maybe the user started doing something else, maybe they started navigating or reading through your app, never abruptly just pop things into existence, maybe have some kind of way of nudging the user like, hey, the download completed, now you can use this new feature. And the second state I wanted to mention is the user confirmation state. So if your module is really big, if it's something over 10 megabytes, I don't think we published the exact limit. That might change from version to version. But if your module is really big and Play decides that it needs explicit user confirmation that they want to download this amount of data right now, you will get this status, and the installation will not proceed until you call start confirmation dialog for result, and then handle it on activity result if the user confirmed that they want to continue with the installation, or if they canceled it. And this is how it looks. We just pop up a small dialog from Play asking if the user is really sure they want to download this amount of data. When they press download, you will continue with your installation as usual. Now, there's one more important API call that I want to mention, and this is the API for uninstalling modules. So if you no longer need a module, if a user, for example, hasn't used it for a long time and you decide you just want to free up some space on the device, you can do a deferred uninstall of a number of modules. Again, the success listener just means that this request was approved by Play, it was received by Play. The thing is, uninstallation is always deferred. So don't be surprised if you get a success, but the module is still there. It'll still be there for some time until Play does its maintenance, maybe in the next 24 hours, and only then it'll delete the module. So deletion is not instantaneous. It'll happen sometime in the future. The fun fact that I mentioned before about install time modules, which are otherwise kind of boring because they don't do much, is you can actually uninstall install time modules. So not only on-demand modules that you installed at runtime can be uninstalled. You can take this big install time module. I mentioned the scenario with the huge video file that's only available at sign-in. Why not uninstalling it after the user goes through the sign-in flow, through the onboarding flow, and you free up a lot of space on the user's device. And the next time the user updates your app from Play, if they get a new version, Play will remember that this install time module was uninstalled and will not pull it down and install it again. So that's pretty cool. Now, I mentioned some of the UX practices, like always notifying the user about what's going on, not popping things into existence on the screen if the user navigated away from installing the module. We actually have a whole page on DAC if you look on developer-android.com. If you look for UX best practices, we list some of these scenarios that would be nice to handle in your apps if you're doing on-demand loading. Now, there's one more thing I want to talk about, and it's testing dynamic feature modules, which is usually a big problem for developers because you cannot do it easily from Android Studio locally. The way this whole on-demand thing is set up, the way the PlayCore works, it always communicates with the Play Store on the user's device, and then the Play Store, of course, communicates with the Play servers. And the whole magic of transforming Android app bundles into the set of APKs that can be installed also happens on the server, right? So in order to be fully test, even while developing, to fully test this flow, all this state monitoring that I just mentioned on this installing of on-demand modules, you have to go through Play, unfortunately. And so it's not an ideal situation where you would still like to iterate quickly on your app, but on the other hand, you have to have it published on the Play Store. For some time now, we used to have this internal track where you can do it safely within a small subset of users, maybe your developers, and the updates happen very quickly, so you can upload the app and you get updates on your device within a few seconds. It's one of the publishing tracks next to the production track, open and close beta tracks. There's an internal testing track. But it wasn't ideal still for testing on-demand modules because you needed to follow all the requirements that Play puts on uploading new versions of your app. You needed to upload unique version codes. So every time you change something in your app, you needed to raise the version code, build your app again, upload it again. You had to use the signing that you would normally use with your app. And you couldn't upload debuggable apps. So if you want to iterate quickly and find the bugs in your code when you're implementing all these on-demand magic, then you couldn't do it easily because the app on the Play Store is not debuggable. Now, not many developers are aware. We now have this internal sharing, which is it's not the internal track. It's completely a different section in the Play console. It's meant for ad hoc sharing within development teams for up to 100 users, where all of these requirements are gone, and you can suddenly upload all kinds of APKs without caring about the version code. It can even be lower than the one you previously uploaded. You don't even have to care about signing the app. The Play Store will generate a special internal sharing signing key and will sign it for you. And also, you can upload debuggable apps. So even if you download an app from the internal sharing track, you will still be able to connect ADB and debug what's happening in your code. And how does installation happen? Users don't have to sign up for a specific track, like for the open and close betas. They just install the artifact via a URL. How to use it? Well, first, there's a one-time setup step that any users that want to download from internal sharing have to do. They have to go to the Play Store settings, tap a few times on the Play Store version, just like enabling debug mode on Android. And then a new option shows up, internal app sharing, turn it on, and from now on, you can access these URL links for installing applications from the internal sharing track. Next, you go to the Play console, you upload a bundle to the internal sharing, you get a URL back, you copy that link, paste it into the device, and you get a page that lets you open Play Store. And it's a very, very simplified page just listing that specific version of your app, and you click install and you get it. The thing is, once you upload more bundles here, you'll be able to get specific links for the specific versions that you uploaded, and you can just download them and install them on the device without caring again about version codes and stuff like that. Now it would be really nice if we could automate this. Unfortunately, we don't do it ourselves from Gradle yet. Android Studio doesn't fully support automating these uploads to the internal sharing. There's an unofficial Gradle plugin. Now, take care, this is not made by Google, but many developers from the community find success using it. So it's open source. If you're worried about it, please look at the source code, make sure that's something you want to use. And it can actually give you a Gradle task that does that upload to internal app sharing and simply gives you back a URL you can launch on your device. So yeah, there's a few things we covered, such as split installation, on-demand splits, how to handle UX and accessing code via reflection. But there's more to PlayCore, like I mentioned. There's the language splits installation. There's in-app updates, which are amazing. And finally, there's a way of instant enabling your bundles. So certain modules in your project can be marked as instant, and then you can create an instant app out of that single bundle that you publish. So please look at our documentation on developer-android.com, and you will find all the instructions in there. Now, like I said, I know that maybe the API isn't ideal. There's a lot of steps you have to go through to monitor the progress of the installation. And we are currently investigating, based on some of your feedback, the developers' feedback at conferences like this and online, how to make the API less verbose, so you need to type less code, how to make it more Kotlin-friendly. There's one thing you cannot do currently if you're using Jetpack navigation, the architecture component for navigating within your app. There's really no way right now, no good way to navigate into destinations that are defined in dynamic feature modules. That's something we're currently investigating as well. And also with the testing, we know it's not always ideal if you want to just run it test locally in your app to have to go through the Play Store. So we're investigating if we can support local testing during development. And yeah, please watch the talk on dynamic delivery in about 2 weeks at Android Dev Summit. We might be announcing some things. Okay, thank you. And find me if you have any questions. Thanks.